Alright, this video is about the different types of extrema. Now there's two types of extrema. There's relative extrema and absolute extrema. What the difference is relative extrema is local. Right? It's relative to what part of the graph you're looking at. For instance, say you had a cubic graph, like so. Right? This would be your relative or your local max. You'll probably see it referred to as a relative max more often. And this point here, all right, this would be your relative min, or of course the local min. But like I said, you'll see it referred to as relative more often probably. Now the reason is because obviously the max for this would be positive infinity. That would be your absolute max. And your absolute min for this would be negative infinity. But you can't actually get there, right? But say you're only dealing with an interval, right? This would be your relative max and min. Now, absolute maxes and mins. Say you have the graph y equals x squared. Well, that's a parabola that opens up, right? So we know that both ends on this, on this side go to positive infinity, which means that our vertex down here is going to be the smallest or the lowest it's ever going to go. So that would be an absolute min, meaning it is not going to get smaller than that. That's going to be an absolute. There's nothing going to get smaller. Like here, this is only a relative because we go up and then come back down. Whereas this, there's no part of this graph that will ever go below that min right there. Same with the max. Say we flipped it upside down. Okay. All right. Now our vertex, because both of these sides here would go down to negative infinity. So now this point would be an absolute max because it's not going to go any higher than that point. So it's going to be an absolute max. All right. Now, as a little side note here, I don't know what that's supposed to be. Looks like cold. Now, you can only declare absolutes if the following. All right, so you can only call it an absolute min or an absolute max. All right, let me move this out of the way. You can only call it absolute if you know, all right, you have to absolutely positively know a graph again, I don't know what I was writing there. Goes infinity in one direction and never lower or higher. All right, so it goes to infinity goes to infinity in the other direction. Like for instance here, you have your min right here. So you have to know that this goes to infinity in this direction, or in this case, here is our max, so it goes to negative infinity here. That's what means. That's what it means by goes to infinity in the other direction. So it could go to positive infinity, but it could also go to negative infinity, okay, in the other direction. Let's see. And never gets lower or higher. All right, that'll be more clear when we start to do some problems. But you can only declare absolute, like for instance, we can only call this an absolute min if we know that these two sides of the graph go to positive infinity. So it'll never come back down and go below here. Same thing here, we can only call this an absolute max if we know both of these sides go to negative infinity. So therefore it's never going to go higher than this point. Alright, now the only other case you're allowed to declare absolute, okay, and make sure you remember this, is if you are given endpoints for an interval. So if they give you an interval, say from negative 1 to 2, you can declare an absolute min and or max. Well, it'd only be one or the other. You can declare an absolute min or max over that interval because they only want from negative 1 to 2. All right? Let's solve a problem to make some of this seem a little easier. So find the absolute extrema on the interval negative 1 to 2 for f of x equals 3x to the fourth minus 4x cubed. So if you remember from yesterday, step 1 is get f prime of x. So f prime of x equals 12x cubed minus 12x squared. All right, step 2. We need to get our critical values. All right, so how did we do that? Remember, you set f prime, you can set it to d does not exist, which means the square root of a negative number, which in this case we can't do because we don't have any square roots, or 1 over 0. All right, we don't have any of those. All right, so we're done with that. We don't need that. Second one, f prime. Now we need to set it equal to 0. So we're going to take our 12x cubed minus 12x squared, set it equal to nothing. All right, you can factor out a 12x and get x squared minus, I'm sorry, let's factor out an x squared and get x minus 1 equals 0. All right, for finding the extrema, this 12 is really useless. All right, so what we have is x squared equals 0. So x simply equals 0. And over here, we have x minus 1 equals 0. So x equals 1. All right. So now our critical values that we just found were x equals 0 and x equals 1. But now, we also can't forget about our endpoints, all right? Because our endpoints might be our max or min. All right, so we can't forget about our endpoints either. So we're also going to have to test our endpoints. All right, we're also going to have to test our endpoints. All right, so step 3 is use f of x to find the overall max min. All right, so let me pull this up a little bit. So let's go ahead and plug in x equals negative 1. Well, if we plug in x equals negative 1, we are going to get 3 times, okay, because negative 1 to the fourth is positive 1, so we're going to get 3 minus negative 1 cubed is negative 1, so it's going to be negative 3 minus negative 4, which of course the double negative becomes a positive, and this gives us 7. All right, now let's just do them in numerical order. Let's test the 0. So if you plug in a 0, you get, well, nothing. All right, let's plug in x equals 1. So we're going to get 3 minus 4, which is negative 1. And now let's plug in x equals 2. So if we plug in x equals 2, we get 3 times 16 minus 32. I just plug that straight into here, which equals 16. All right, so now we've tested our two critical values that we found. We found x equals 0 and x equals 1 to be our critical values. And then our endpoints are x equals negative 1 and x equals 2. So now what we want to do is we want to look at our values that we got. All right, the lowest value will be where our min is located, and the highest value will be where our max is located. Okay, so because we have an interval, we're going to have both a max and a min. Okay, if we didn't have an interval, we would only have one. All right, so where's the smallest? Well, the smallest looks like negative 1. So at x equals 1 is our absolute min, because that is our lowest value. And then we'd find our highest value. Well, that's at x equals 2. So at x equals 2 is our absolute max, because 16 is the highest and negative 1 is the lowest. So our absolute min is found at x equals 1, and our absolute max is found at x equals 2. All right. So now let's look at intervals real quick. This will be the last thing we go over. There's no ticket in the door for this one. Say we had the interval from A to B of some graph. Let's make it look like that. All right. For this graph, are we going to have an absolute max? Yes, we are. It's going to be right here. So we are going to have an absolute max. Are we going to have an absolute min? Well, yes, we are. Same thing there. All right. So when your interval's closed on both sides, you have both a min and a max, like we found here. It was closed on both sides, so we have a min and a max. What about if it's open on one side? Right, so it doesn't include the b. So our graph may look like this. But then we'll have an open circle. Oh, let me label this. This is A, this is B. And A, B. All right, are we going to have an absolute max? At first it might be, well, yeah, because it stops there. But this doesn't include B, so it's going to get infinitely closer to B. So you could give me a number, and I could find you one higher. And then you could find one higher, and then I could find another one higher. So if your interval does not include both numbers, all right, just like if this had been this, we would not have a min in this case. So this is no max, and this would be no min. All right, but referring to this one again, we would have an absolute min. Okay, so just keep in mind, if if your interval does not include one of your numbers, okay, one of your endpoints, like here it doesn't include the b, so it would have no max. Here it does not include the a, so we would have no min. All right. And then our last one is A comma B. So you'd have open circle, your graph, another open circle. So for this one, you would have no absolutes, okay? Because it doesn't include either. Because again, say this was 1 and 2, not including 1, not including 2. Right? So you're like, well, the smallest you can be is 1.001. Well, I'll be like, no, because 1.0001 is smaller. And then you could put 4 zeros in there and say, well, that's even smaller. All right. Same thing here. You could do 1.999. Well, then I could throw another 9 on. You could throw another 9 on. So we could keep making the number bigger. So we would never actually get to the largest value. Kind of like you can't get into infinity, you can't actually get to the largest value that is smaller than 2. All right. So just know, if they're both endpoints are included, you'll have a max and a min. If your if your highest endpoint is not included, you'll have no max. If your lowest one, you'll have no min. And here we have no min or max. All right, no min or max. All right. So make sure you understand the two different types of extrema and how to find them, and if you even need to waste your time trying to find them because they don't exist, as in these last two examples here. All right. So that's it for this video. Make sure you understand this. See you tomorrow.